Hi, grade 10. So today we are going to start our little intro into physics. And this is actually a skill we're going to learn today that transfers into physics and chemistry. And that will actually take you, I know we didn't use it in chem, but it'll take you into Chem 20 and Chem 30 and Physics 20 and Physics 30. And it will make a big difference in regards to final answers. So it is, if you wanted to title your notes, sig digs or significant digits and scientific notation. So what we're going to look at right off the bat is, what does significant digits mean? Okay, so in science, when a number is stated, it tells you the value of the number and actually the accuracy. So what accuracy means is, how precise is it? So if you're looking at the example, which is more accurate, A or B, 1.1 times 10 to the 3 meters away, or 1,132.10 meters away? Well, this one is actually more accurate right there. So what we're going to do is we're going to look at our questions we're given and decide on the precision of the number that's actually being represented. And then we use significant digits and scientific notation to indicate that. So this is something that I would have you write down if you had you in class. These are our rules for counting. I wouldn't necessarily write down the first part. I'm just going to explain it. What it means is you go from left to right, just like we would read normally. We start counting at the first non-zero digit, which means any other number except 0. You keep counting until you reach the end, no matter what digits you end up passing. Okay, so what that means is zeros at the beginning are not significant. We do not count these. So in this example, we pass over this zero, this guy, this guy. We only count the 2 and the 1. So this actually has 2 significant digits, or what you're going to hear me call them is sig digs. Now, zeros within a number are always significant. So we're counting here 1, 2, 3, 4 sig digs. And also in this one, 1, 2, 3, 4 sig digs. Trailing zeros that aren't needed to hold the decimal are still significant. There is a difference between 4 and 4.00 in regards to accuracy. So if we're looking at this example, 4.00 actually has 3 significant digits. Moving on, try a couple examples. So all of these do have 3 sig digs. So our first one, 1, 2, 3, obviously has 3 sig digs. We don't count the 0 here, so 1, 2, 3. We don't count the front zeros, but we count the end. So there's 3. Now there is 3 sig digs here. So that got a little crazy. We do not count scientific notation, which looks like times 10 to the power of 3. We do not count that as part of our significant digits. And our last one, the middle zeros do count, so this also has 3 sig digs. So examples, if you want, pause, try them, and then I will do them. So pause, maybe. This one should have 1, 2, 3, 4, 5 sig digs. This one, don't count the front 0. 1, 2, 3, 4 sig digs. And this one, 1, 2, 3 sig digs. We do not count this to power times 10 to the power of 6. That is our scientific notation that we're going to clarify, but it should look familiar from math class. Okay. Oh, I think I skipped a page, didn't I? Nope. So we are going to look at adding and subtracting. Now, what does it mean when we're actually doing math or physics calculations with significant digits, and you actually have to provide an answer. If there are different rules for adding and subtracting, okay, one rule for those two, and one rule for multiplying and dividing. You are mostly in physics going to only worry about our multiplying and dividing one, but I am going to show you the addition and subtraction so that you are aware of it. So for addition and subtraction, you are going to always have your answer. So something I would write down is the same number of decimal places. So this is strictly decimal places, nothing to do with the counting of the sig digs that I was talking about, to the least accurate. Okay, so what that means, least accurate, well, what is more accurate, 5.10 or 5.1? This is less accurate. This guy is more accurate. And so, example, if you add 0.507 grams to 150, so why not show our work? Okay. And this should equal, if we type it into our calculator, 150.507. Now, our rules for sig digs or answers are the following for adding. Must contain the same number of decimal places as the least accurate measurement. So if we're looking at our two original numbers, the 150 actually only has one decimal place. So this one is our least accurate. So that means we get one decimal place in this example. So our answer is actually 150.5 grams. Moving on to multiplying and dividing. What does this look like? Okay. For multiplying and dividing, this is, I said, the important one. It has to contain the same number of sig digs as the number that you're dealing with. So out of all the numbers in the original question, what are you dealing with? With the least number of sig digs. So you are going to actually have to count the sig digs in each one of your original numbers and then use the one with the least amount. So what I would do is, if I am multiplying 2.50 and 18.02, I'm going to count this number, the sig digs. So I am counting 3 sig digs in this question, or in this number. I am counting 4 sig digs in this number. So I have to go with the least number of sig digs. So I only get 3 sig digs. So when I multiply this out, I should get 45.05 in my calculator. Okay, and it might be a good habit to write this down just so that if you do mess up on your sig digs, you can actually see why and know that you actually got the rest of the question right. It was just this last little part that you need practice on. So now looking at this answer, this actually has 4 sig digs, but I only need 3. So that means I'm going to actually have 45 point, and I only get this one decimal because I need 3. Now this 5 beside it, whatever number is beside the last decimal place will always influence rounding, just like you've done in the past for math. Okay, so 5 and up means you're going to round up. 4 and down means it stays the same. So if this was a 3 instead of a 5, this would be 45.0. But because it's a 5, this is actually 45.1. And then we always throw our units in there, which is grams. Okay, exception to the rule. If the number is exact, you don't have to follow those rules. So for example, if it's telling you you have a dozen, that's an exact number. That's 12. Okay, I am not counting only 2 sig digs here. That is not an accurate representation of what we are dealing with. I am actually going to get 5 sig digs in this question. So when I multiply it, 12 times 167.21 grams, I should get 2006.52. With 5 sig digs, I am going to go with 1, 2, 3, 4. I gotta stop here. So 2006 point, this 2, which I don't get to include, influences my rounding, which means it stays the same. So therefore, I have 2006.5 grams, okay? So, scientific notation. What does this mean? If you're asked to put something into scientific notation, you're often needing to do this when you have a really, 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 really big number. Let's say like 100,255, but you only get 3 sig digs. Well, you can't round away that. You can only round away decimals. So what we do is we use scientific notation. So scientific notation has to be a number between 1 and 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But not 10, because it has to be between them. So if I was doing this, okay, and I am looking at this question, and I am saying, okay, this is a really big number. I might eventually end up having to put it into, let's say, a smaller sig dig. I would have to know how to put this into scientific notation. So what this looks like without dealing with sig digs, 4,159.25 can actually also be wrote as 4.15923 times 10 to the power of 3. Okay, and that's because I've actually moved the decimal place 1, 2, 3 places to get a decimal between the 4 and the 1, because I want a number between 1 and 10. 4 is between 1 and 10. Okay, so, and then I write, okay, I have moved that decimal place 3 times, which essentially means in math, I have actually, okay, I'm just going to take that 415,923 and I am multiplying it by 10 to the power of 3. Now, if you were wondering what that means for your calculator and how you can check it, take this little guy out, okay, and if you look on your graphing calculator, okay, you can do this a couple ways. Some of you are great with to the power of, but if you're looking just for the power of 10, it is actually above the log button, which means you're going to go second log. So if I wanted to do this in my calculator, okay, I would, and confirm that I did it right, I'd say, okay, well, my answer that I want to make sure is that number, 4.15923. I'm going to go just type that number in, okay, times, and then I'm going to go second log. So then I see 10 to the power of 3. And that gives me 4,159.2. Oh, there's a number mistake. 3. Okay, we're going to make that, that's a 3. Okay, so our second one, 0.02654, I'm going to move it 1, 2. I'm going to stop when I get a number between 1 and 10, which is 2. So 2.654, how many times did I move that decimal? 1, 2, okay, to the negative 2. And that is because this was a decimal number. So if you're dealing with a small number, and in my world, you're dealing with decimals, usually, or if it's just a really tiny number, also known as if you're moving the decimal point to the right, okay, you're going to go 10 to the negative 2. And you can check it with your calculator to make sure you have the right power. If you thought it was positive 2, you would actually see that would be a really big number. Okay, and when it's 10 to the power of 3, this is a big number. Trying a practice question. So what does this mean? Convert 0.03127 kilograms to scientific notation with the same number sig digs. So I'm going to count my sig digs first. 1, 2, 3, 4. So I get 4 sig digs. Scientific notation tells me I need to move my decimal place. So 1, 2, 3, stopping when I get to a number between 1 and 10. So I'm going to then have 3.127 kilograms. And that has 1, 2, 3, 4 sig digs. Oh, sorry, guys. I should insert right before the kilograms. Times 10 to the power of how many times did I move the decimal? 1, 2, 3 kilograms. There's my units. All right. Next question. Convert 1564.7 meters to scientific notation with 3 sig digs. So that's all I get, just 3. So if I need to convert this into scientific notation, I'm going to move my decimal 1, 2, 3. Okay, 1.5647 times 10 to the power of, and I moved it 3 times. Okay. And it is a big number, so it's to the power of 3. Sorry, I forgot the negative on this one. This was a small number, it was negative 3. Now, I only get 3 sig digs. So I only get 1, 2, 3, which means I have to get rid of these guys. 1.56, and that 4 means nothing round, so see you later. Times 10 to the power of 3, and then throw my units in at the end. Okay. Now, I'd really love for you to practice this and then complete a little assessment. If you want to just go for it and try the Google form right off the bat, the Google form is attached, or you can practice what the quiz is. Hope this all makes sense. Let me know if you have any questions or comments. Bye, guys.